Alright, so this is just a power supply from a laptop, a 30 volt power supply, and this is a buck converter. It's a step up or step down converter. Right here we've got the voltage of the batteries. This is 32 Celsius, around 83 degrees I suppose, and we have 30 volts, 30.12 volts coming in. So I'm turning it on at this point, and right now it's set for 27.93 volts, and you see the amps at the bottom, 1.726. So I am going to slowly crank this up because it does like to shut off at 2 amps. It's got a limiter in it. And alright, so I've got it set for 27.95 volts. And what happens with this battery, it's a couple of Nissan Leaf batteries. Once it hits that voltage, the amps will drop off completely. So the next battery we're testing out here is a 12 volt battery, just a small tractor battery, and I'm going to set this for around 13.5 volts. Also watching the amps at the bottom to make sure that the amps don't get too high and shut this off. It does have an overcurrent limiter, which is nice, and once it reaches the 13.58 volts, it'll shut down the amps completely. So very nice to use this way. Okay, I pulled this rigid battery straight off the charger, and it's completely full, and I'm cranking the voltage up, but because of the internal BMS of this battery, no current is going in. So I've got a Ryobi battery and it's not quite charged up, and I'm going to turn it on. Alright, I've got it set for 19.98 volts, and at the bottom the amps are going in. So next is a nickel cadmium, I believe it's nickel cobalt battery. It's one of a Nissan Leaf battery. Alright, so our second battery charger is going to be just a simple bridge set rectifier and a capacitor. Now it's probably better to use a small capacitor at first, and then you can always work up to several capacitors at the same time. But if you get too big of capacitors, then you're going to need a bridge set rectifier that has a heat sink and also can handle the additional amps. Alright, so this isn't very hard to put together. I've just simply made up some jumper cables, and we're gonna hook that up right now. So we got our positive. I labeled it with red tape, and on one side there's a plus sign, so that's your positive, and then the negative just goes diagonally from it. And so on the other side, you see here where it says AC. So we're just going to use a simple jump cord, and this side is hot. See how smooth that is. On the other side, if you can make out these lines, they go down the length of it. That's going to make that one the neutral. It actually doesn't matter how this is hooked up, but I like to put the capacitor with the hot and then go to the other side of the AC with the neutral, and then on your opposite side of your capacitor you would just hook that up where it says AC in. So this one I would suggest most people not make. If you make this, of course, you're on your own. There's no safety measures built into this, but being a small capacitor, it doesn't carry a lot of amps, but what it does carry is a lot of voltage. So if you're going to use something like this, you would first hook it up to your battery and then plug in. So we're going to do that. Alright, so we have got our battery charger. This, you would want to cover everything up except for the outlet if you were going to use something like this, and make 100% sure that you are hooked up to the battery to absorb the capacitor before you plug it in. If you do those things, you'll eliminate 99% of the danger. So we're just going to plug this in real quick. This battery doesn't get used very often. It's a food truck and we don't drive it around too awful much, but let's see, the voltage is starting to pick up here. This style charger, however, has been used for a long time. It's actually a pulsating charger because of the capacitor. So you get a lot of pulsations, and this is supposed to get rid of the sulfation on the battery. And the RC World has claimed that they have used this style charger to charge their RC batteries, and that they have maintained batteries for 10 years without any noticeable degradation. I don't know about all that, but I've used this charger myself in the past for the lead acid batteries. And the biggest thing you want to be aware of is that you keep your batteries filled, especially if you're going to plug this in and leave it and forget it. If you're going to do something like that, you want a small capacitor. If you're not actually trying to charge the batteries up rapidly and then use the voltage and the amps off of the battery, if you were going to do something like that, then you'd want multiple capacitors and also a bridge set rectifier with a heat sink and, you know, higher capacity. But this works very good, especially if you're trying to charge up large battery banks and you don't mind doing it slowly. If you need to do it more rapid, you'd use larger capacitor and several capacitors and larger bridge set diode. But you could use this on forklift batteries, 48 volt in nature. This style charger doesn't care about the voltage. It only tries to reach the capacity, and then it's supposed to float and stop. Not quite sure if it does that or not. I would imagine the less capacitors you have charging up your battery, the more chance you have at stopping. Now, if anybody has an idea how to get this up to voltage, say 14 volts, and that gets set on a relay and the relay would kick off the 110 volts, that would be pretty interesting, because you could have it set for, I don't know, 13.8 volts, and then when it reaches the 13.8 volts, it would trigger a relay, and that relay would kick off one of your legs of the 120, well, the hot leg of your 110. That would be another nice little project, making this battery charger very important. Anyway, we're going to throw this on another battery and see how it does. Alright, so I'm going to talk real slow here. This is one of those do not try this at home. You see we got 193.78 volts, somewhere around in there. This is the battery pack to a Toyota Prius. I've got it hooked up. This is a service port. It's totally live right now, but if we cut this off, it removes all voltage to this part right here. Let me zoom in on this. So, can this battery charger, again, wrap everything up and only see this part, but can this battery charger charge this style battery? I would imagine it would have no problem charging it, but please consider all the problems. You know, if you have a bad battery, is it going to cause friction? Is it going to cause a problem? You know, is one of these batteries going to swell? Is it going to heat up, perhaps catch fire? I don't know, and you can't possibly know either. But I am going to show you that this style charger could, you know, providing that your batteries are healthy and there's nothing wrong with them, this style charger can charge this battery. Alright, so here we go. But don't do this at home. You know, if you got a bad cell, if there's any type of problem, if your kid wandered into here and started playing and all these shiny parts, you know, this could really end in disaster. So consider all these things if you was going to do it. I don't recommend it at all. If you do it, you do it at your own risk. All right then, so here we go. Gonna pull this fuse back up. All right, we're live. Sorry, I gotta hold the camera myself in this situation. All right, so we are slowly climbing in voltage, and sorry, I wish I knew how to disconnect that audio, but that audio is also very important as well. So you see it's charging this battery, and it's doing a pretty good job of it. Apparently it wasn't discharged very much. So what I'm just going to do is top this off. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. 28 cells times 7.2. I'll put the math on the screen. All right, so that's what I'm going to charge it to, and we'll go from there. All right, so 201.6. We don't have the decimals at this point because we're into the 1000 volts DC. So we're going to turn this off, and we're going to disconnect the power first. That way we don't still have the capacitance on. All right, and now I'll let that bleed down for just a second and disconnect this. And let's talk about this real quick. So the problem with charging it like this, if these cells aren't all perfect, then they're not going to get bounced. And that's why we have all these tiny leads. I'm hoping that this thing does a balanced charge on these individual cells. Now I can tell you though, if you've got a bad cell, let's say this one right here is bad, I have heard of people reconditioning them by simply discharging and pulsate charging and discharging. You know, they do it multiple times until the resistance is gone. I don't know that that would work. That's something you could definitely try if you're going to sit here and monitor it. But I would also order one of these at the same time. Anytime you have a voltage in one of these cells that's you know, greater than 3/10 off, it's probably time to change it. If you want to try to be frugal and recondition it, that's on you. But anyway, this thing is totally awesome. The other one, so this is a buck converter, step up or step down. You can use between 5 and 30 volts on the end, and you can, let's say you have 30 volts going in, you can reduce this down to 5 volts going out, and it's adjustable. You can set the voltage going out. It has a limiter so that if it's pulling too many amps, it'll shut itself down. You know, and then you can slowly turn it up if you were using this as a charger. Its true intended purpose is to use it around computer parts, say like a fan. If it requires 5 volts out of your USB, you could power it up with this instead. And or if you needed to power up a hard drive and you don't have that specific power that it needs, you can adjust the voltage, and this thing will allow it to draw the amps that it needs. And if it's too much, it'll simply shut down. But if the motor, you know, if it's a small motor, this will handle it just fine. Fans, lights, motors, external hard drives. This thing can do lots of things. But remember, it is DC, and it's only limited to 2 amps. I have kicked out 2.6, and that was on this Prius. I wanted to see what would happen if I ramped the voltage up, and it didn't kick off. But on the 12 volt battery, it did. And I don't know if it was just limiting the watts, because on the 12 volt battery inside, anything over 2 amps, especially that big battery pack that you saw, anything over 2 amps and this thing just automatically shut down. So I just adjusted this rheostat here on the far right, this one right here, But this thing's amazing, and you can do all sorts of things with it. It's a nice power supply, and just like the one I showed in a different video. But this one's more versatile because you can adjust the volts from 5 to 30. And the input voltage is not really sensitive either. It can be from 5 to 30, but the higher the voltage going in, and the less amps will pass through certain parts of the configuration here. So keep that in mind. If you're only throwing 5 volts on the in right here, it does struggle a little bit. But putting the 30 volt power supply, such as this one from a computer, works great. And if you just happen to have the right size plug, you don't even have to wire it up. You can just plug it in right here. Well, that's it. I hope you appreciate this video. If you have any ideas how to regulate the capacitor Bridgeset diode charger, I would love to hear it. That thing is pretty awesome. It's very efficient because the only losses are the heat from the Bridgeset diode and also from that capacitor there. So it's pretty well efficient, and it works well too. It's not quite the set and forget that you would want in a lot of the chargers. It's one that, you know, you'd plug it in the next day, unplug, I would imagine. But I've left it plugged in for months without any trouble. Again, watch your water levels because it's trying to push it, but generally when it hits between 13.8 and 14 volts on a 12 volt battery, it just hangs there. So it's great. It is dangerous, however, if it's not set up correctly. You'd almost want those terminals covered in something so that no one could accidentally touch them if they weren't aware that you have to hook it up first and then but again, if we had some type of over voltage monitor that would shut off the 110, that one would be awesome as well. So anyway, hope you've enjoyed this video. Got a lot more on the way. Got nothing else to do except for projects. All right, thanks again. See you.